Hello everyone, welcome to the Mercury Virtual. Hope you are doing good. Today I'm going to continue with your uh, module, that is the procedural programming. So I'm continuing with the C programming, that is the procedural programming. Till now we have covered about the sixth chapter, that is the data type revisited. In the last class we have discussed about the different data types, different integer values, different types of data type like int, char, float, and different categories of the int, different categories of the float. In the today's class I'm going to continue with your chapter number 7, that is a C preprocessor. That is a today's topic. But before this, let's take a quick review what we have covered in the last class. That is a chapter number 6 we have studied in the last class, that is a data type revisited. So let's take a quick review. In this we have studied what is a data type. So it represents the type of the data, that is a data type. So any data or any variable of int type, that is a data type. Float, that is a data type. So any type of data, or it may seem that C programmers manage with tiny sets of data type that can be derived or that can be deprived with the C programmers. A C programmer can always invent whatever data type he needs, that is whatever data type he needs or he or she needs, that he or she may take up. So if I define the variable that should be of one data type, that is either take integer value, either take float value, either take character value. So generally there are primary three types of data type. What are the primary data types? That is int, char, and the float, that is a real values. Then we have studied about the integers, that is what are the types of a data type that is available for integer, that is long and the short. So one of the category of integer is long integer and one of the category is short integer. It depends on the compiler to compiler that we are using. If we are using 16-bit compiler, that is a different issue. If we are using 32-bit compiler, that is a different issue. So there are different kinds of integer, that is either long and the short, and the range is also differ from the compiler to compiler, differ from the long to the short. C offers integer data type that we provide are the short and the long integer values. Short are at least 2 bytes long, that is the short integer at least 2 bytes long, that it can store at least 2 bytes. Long can store at least 4 bytes. Short are never bigger than the int, and int are never bigger than the long. So first of all there is a long, so there is a short, then there is a long, then there is a integer. This is the example, this is the compiler. For example, short takes 2, 2, 2. Long variable which which hold long integers are declared using the keyword long, as in this one. So it is declared as a long by using the keyword, that is a long. Then we have discussed various examples of the short, various examples of the long. Then next category of the integer that we have discussed in the last class is that the integer can be of the signed integer as well as the unsigned integer. We generally use, or we commonly use, the signed integers. That is the signed integer, that is it can store without any sign, without any capacity. It has a low capacity or the less capacity than the unsigned integers. In such case we declare the variable as a unsigned. That is, we declare the variable as a unsigned whenever we want the range, that is from 0 to 65535. That is unsigned char. Like an unsigned int, there also exists a short unsigned int and a long unsigned int. By default, a short int is a signed short int and the long int is a signed long int. That is, by default the category of the int is of the signed, but we can choose, or we can opt, or we can make the unsigned integer also. Then next category is char, that is either signed and the unsigned. So one category we have finished, that is integer data type, and the types are long, short, signed, unsigned. The next category is chars, that is either signed, unsigned, or the long and the there is no long and short in char, but only there are two categories, one is signed, one is unsigned. Parallel to the signed and unsigned int, similarly there also exists signed and the unsigned chars. Like in the same way, we have done, or we have covered with the signed and the unsigned int. In the same way, there also exists the unsigned and the signed chars, both occupying 1 byte each, because char takes only 1 byte, but having different ranges. To begin with, it might appear strange as to how a char can have a sign. Consider the following statement. This is the statement that is taken as a char as a, or ch as a, that is a binary equivalent of the ASCII value. A signed char is same as the ordinary char, but has a range that is from -128 to 127. These are the example that we have discussed. We have discussed about the character that takes the ASCII value. And then we have discussed about the float and the double data type. That what is a float and what is a double data type. A float occupies or takes 4 bytes in the memory and have a range -3.4 E38 to the +3.4 E38. If this is insufficient, there is another data type that is available, that is a double. If double is also insufficient, that takes 8 bytes or that stores 8 bytes. That there is also a procedure, there is also a provision that we can use the long double that takes or that holds 10 bytes of data. That is a long double. Let us now write a program that holds the value, that holds the data. So this is the example that we have discussed, and this is the crux that we have what we have covered in the last class. This is the table that represents the data type, the range, the bytes, and the format specifier that is used. C is used for the char, D is used for the int, U is used for the unsigned int, long signed there is a LD, long unsigned there is a LU, float F, double LF, and the long double, capital L and the small f. Then we will discuss about the issues that is available about the data type. Then next category, next topic that we have discussed is the storage classes in C. That is, what are the storage classes, or in which class the data or the variable will arrive. That is the storage classes in C. This says to fully define a variable, one need to mention not only its type but also its storage class. That is, if there is no storage class is given, that takes the automatic storage class. But not only the data type we specify, but we specify also the storage. In other words, not only do all variables have a data type, but they have a storage class also. We have not mentioned storage classes yet, though we have written several programs in C. That is, we have not mentioned. Why? Because they have taken the storage class as a default storage class. So there are 4 categories of storage class that we have discussed. One is automatic, one is register, one is static, one is external. So these are the 4 categories of the storage classes. So now we have discussed in detail what is the automatic, what is the register, what is static, what is external. So in simple terms, in automatic storage class, the storage or the memory or the storage capacity or the storage is done in the memory. That is the automatic storage class. Then we have discussed about the register storage class, in which the storage is done, that is the it can store the data in the CPU registers that give the garbage value, that is any value that is given as the default initial value. Then third category is static storage class. That is, we can also make the static storage class that have a storage or that stores the data in the memory. This is the example. Then we have discussed about the last category, that is your external storage class that have a storage in memory. Default value is 0, initial value is 0, scope is the global. That is when we define the global variable, that is beyond the main function, that can be accessed by any of the function, that can be accessed by any of the variable in the program, that is known as the external, or that is done by the external storage class. We can specify by using the keyword like extern, that is the extern. This is the example of the storage class. Then we have discussed which to use when, that is what to use when, or the which storage class is to use when. So it depends on the programmer to programmer, it depends on the different conditions. What are the two conditions? That economize, that is that gives the benefit to the programmer, that saves the memory, or that utilize the memory very well. First point is that one. The next point is that improves the speed of the execution of the program. So these are the two scenarios that we use whenever we done or whenever we choose the storage classes. The rules are as follows. These are the rules. Use this one if we want the storage class to be use the storage class only and only if you want the value to be persist between the different function calls. Use the register storage class whenever we use or whenever we have to store the variables in the memory. Use the external storage class that are being used by almost all the functions in the program. But if you do not have any of the express needs mentioned above, then use the auto storage class. That is, if there is no any method, there is no anything that is you want, then use the storage class or the automatic storage class. This is what we have covered in the last class. Then at last we have studied, or we have covered the summary and the question and answer that is given in this book. Now if you have any doubts, then please clear the doubts at the end of the session. So now let's move to the next chapter, that is the chapter number 7, C Preprocessor. So let's start with the today's topic, that is the C Preprocessor. That is in this we are going to cover the few topics. What are the topics? First of all, features. That is, what is the feature that is available for the C Preprocessor? What is C Preprocessor? What is the macro? Why we are using the macro? Then macro expansion. Macro expansion means how we can utilize or how we can use the macro in the C language. Then macros with the argument, macro versus function, file inclusion, conditional compilation, if, else if, undef, pragma directive, summary, and the exercise. So these are the few content of this chapter. So let's start with the C preprocessor definition. This says the C processor is exactly what its names apply. That is it is the same what it names. That is a C preprocessor. That is before the processing, whatever the output, whatever the input, that is a C preprocessor. It is a program that processes our source program before it is passed to the compiler. So it is known as, or it is any program that process our C program. That process means that executes our C program, our source program, before it is passed to the compiler. So this is a phase that lies before the compilation part. Suppose we have written the program. After writing the program, a process that processes the program, that executes the program before it been passed to the compiler for the converting into the machine language. That process or that method or that step is known as C preprocessor. Right? Preprocessor commands, often known as the directives. So if I say preprocessor, what is C preprocessor? That is known as the directives. Preprocessor commands form what can almost be considered a language within the C language. We can certainly write C programs without knowing anything about the preprocessor or its facility. That is, we can certainly write the C programmer or C programs without knowing anything about the preprocessor. But it is a great convenience that we use or whenever the programmer relies on the preprocessor. This chapter discusses about the preprocessor directive and the pros and the cons of using them in the program. So in simple terms, before compilation there is a step that executes, that process RC program, that is known as the C preprocessor. Right. Now what are the features of C preprocessor? That is, what are the qualities, what are the characteristics of the C preprocessor? There are several steps that involve from the stage of writing a C program to the stage of getting it executed. That is, there are multiple steps that we are using, or that we are involving, that is from the starting or from the stage of writing a C program to the stage of getting it executed. Figure 7.1 shows these steps along with the files created during each step. This is the figure that shows how compilation or how preprocessing is done. This is a topic that we have discussed in the computer system module, computer system concept or the topic very well, that is in detail, preprocessor of the C. Note that you can observe from the figure that our program passes through several processes or processors before it is ready to be executed. The input and output is shown in the 7.2. So this is 7.1. First of all, there is a handwritten program. That is, a handwritten program means any program that is written by the programmer. Then there is a text editor. Text editor means any compiler that is used, for example Turbo C, Turbo C++, that converts the handwritten program into the C source code. That is, that converts, or we can write the handwritten program that is written in the hard copy, that is we can write or we can write that code into the C language, into the C source code that have a default extension .c. This is pr1.c, that is practical1.c. Then there is a concept that we studied, that is a preprocessor. So before compilation there is a preprocessor task that converts the source code into the expanded source code, that is a PRI or PR1.I. Then that code is going, or that code is converted by the compiler. That is, compiler is the process that converts program code into the machine language. That is a compiler. That is, it converts into the object code. So whenever a source code is converted by the compiler, that gives the object code by the extension .obj. So first of all there is a C program, then expanded C program, that is the source code, then there is the object code, that is pr1.obj. Then that is going into the next phase, that is a linker. That is a linking process that links the process, that is a linking. That converts the object code into the executable code, that is the .exe, that is the executable code. So this is the, or these are the steps, or these are the modules, these are the various functions that is using whenever we operate, or whenever the C program executes the program. That is, whenever any program will be executed by the C language. First of all, there is a handwritten program, that is in the hard copy it is handwritten program. Then there is a text editor. Then there is a source code that is given. Then there is a preprocessor that converts into the expanded source code. Then there is a compiler that is that converts the object code or the source code into the object code, that is the pr1.obj, and then linker is going to convert into the executable code that gives the with the extension that is .exe. So these are the various steps how the code will be executed by the C program. Then this is the output. Figure 7.2 is the output of the this one. There is a processor, that is the editor. That is, what is the input? Program typed from the keyboard. Whenever I as a user type the program, that program is typed in the editor, that is a processor. Then what is the output? The output is C source code containing program and processor commands, that is the output. Then there is the next processor, that is a preprocessor. It takes the input as a C source code, this is the processor. Preprocessor that takes the code as a source code and converts and gives the output with the pre-processing command that is properly sorted out. Then next concept is your compiler that takes the source code file. Take this output as an input with pre-processing commands, then gives the output as a relocatable object code. This is the object code that is given or that is taken, that is a pr1.obj. Then next part is your linker. This is a linker that uses the relocatable, or that takes the relocatable object code and the standard C library function and gives the executable code in the machine language, and gives the executable code means the .exe code. So these are the various processors, and these are the input and the output that is taken and given by the processor. Now this is the main hierarchy of the program. If you understood this hierarchy, you understood the basics of the C. So this is the most important. First of all, handwritten program that is typed in the text editor, that gives the output as a C source code, that is taken by the, or that takes the input as a preprocessor, that gives the output as a expanded source code, Then there is a role of the compiler that takes the source code and converts into the object code, that is OBJ. Then linker links the process and makes the and converts the object code into the executable code, that is the pr1.exe. This is also the output of this one. You can observe from the figure that our program passes through several phases. That our program, that is our C program, passes through various phases, various processor before it is ready to be executed. The input and output of these processes are shown or is shown in figure 7.2. Note that if the source code is stored in a file pr1.c, that is if the source code is stored in the file pr1.c, then the expanded source code gets stored in the file that is pr1.i. That is the expanded source code is or this is stored in the pr1.i. So these are the various extensions that is used. One is extension is pr1.i, pr1.obj, then pr1.exe. This is the executable code, this is the object code, and this is the file or the expanded source code. The preprocessor offers several features known as the preprocessor directives. That is, the preprocessor offers or gives various features or the several features that are known as the preprocessor directives. So whenever we take or whenever the C processor converts the object code into the expanded source code, then that takes various features that are known as the preprocessor directives. Each of these directives begin with the hash symbol. This is the mandatory condition. This is the rule. That is, every preprocessor directive starts with the hash symbol. The directive can be placed anywhere in the program, but are often most placed at the beginning of the program. That is, it is advisable to use at the beginning of the program, but it can be used anywhere in the program. That is before the first function definition. We will learn the following preprocessor directives here. What are the types? One is macro expansion, then file inclusion, then conditional compilation, then miscellaneous directive. So let's start with the first one, that is the macro expansion. This is the macro expansion. This is the preprocessor that is used, that is hash define upper 25. That is, define the upper as a 25. That is, define the upper variable as a 25 value. That is hash define upper 25. Then there is a main condition, there is a main function, then uses the int I. That is, uses the first one or uses the this one, that is the int I. Then uses for loop. That is, for I equals to 1, I is less than equals to upper I plus plus. That is, I am using this directive, I am using this preprocessor. So I define first of all upper 25. That is common to everyone. That is, whenever we use or whenever I use upper in the program, that takes the input as a 25. That takes the value as a 25. That is hash define 25 or upper 25. That is, upper has a value 25. And then main int I. So int I means I will be declared as an integer. Then for I equals to 1. That is, it starts with the 1. That is, I has a value 1. Then I is less than equals to upper. I is less than equals to upper means check the condition until it is 25. So it checks for 1, 2, 3, 4 till 25. Then I plus plus. Then printf percentage di. That is, first of all 1 will be printed, 2 will be printed, 3, 4, 5, 6 in the next line, because it is given as a slash n. That is, line by line it is given. First of all 1, 2, 3 till 25 will be printed. So in simple terms, this diagram shows how macro expansion will be used. That is, upper is declared as a 25. That is, upper has a value 25 that is used by any program, by any loop in the program. In this program, instead of writing 25 in the for loop, we are writing in the up form of the upper. That is, we have written the program into the upper, which has already been defined before main statement through the or before a main function to the statement. This statement is known as the macro definition, or more commonly known as the simple macro. So whenever we use the hash define or hash define upper 25, so this is known as the macro directive, macro definition, or simply a macro. What purpose does this serve? Means what is the use of the macro? This says during pre-processing, the preprocessor replaces every occurrence of the upper in the program with 25. As I told you, whenever we use the upper 25, we use the macro, then at every place where I use the upper in the program, that will be replaced by the 25. That is, we declare the upper and then upper will be used as a 25 at every place. Then next point says, this is another example of the macro definition. That is the next example. This is the next example. What is the next example? This defines the PI as a 3.1455 or 3.1415. So it declares the variable, that is the PI variable, as this value. So whenever we use the PI in the program, at every place it will be replaced by the 3.1415. So this is main function. This is the float r equals to 6.25, that is declare the r value as a 6.25. Then float area, that is float area means one more variable is defined, that is the area, that is of float type. Then calculate the area or use the area as a variable for calculating the area. This is PI. PI means this value, that is multiplied by r, that is 6.25, that is again multiplied by r, again 6.25, and then prints the area. So in this 3.1415 it uses the PI value. Upper and PI in the above programs are known as the macro templates, whose values are 25.3.14 are called their corresponding macro expansions. So when we compile the program, before the source code passes to the compiler, it is examined by the C processor for any macro definition. As I told you, this is the step before the compilation. So if there is any macro definition, it will be captured, it will be taken care by the C preprocessor. When it sees the hash define directive, this is the directive that is used, that is the hash define, it goes through the entire program in search of a macro template. Wherever it finds one, it places or replaces the macro template with the appropriate macro expansion. Only after this, the procedure has been completed in a program handed over to the compiler. That is, whole step is first of all followed, and then it passes the cursor and passes the program into the compilation phase. So this is the step that is done before the compilation. In C programming, it is customary to use capital letters for the macro template. That is, it is mandatory to use the capital letter like PI upper in the capital letters. This makes this programmer to pick out the macro template when reading through the program. Note that the macro template and its expansion are separated by the blanks or tabs. That is, we can use the tabs or the blanks for separation. We do not use the commas operator in this one. A space between hash and define is optional. Remember that macro definition never be terminated by the semicolon. Means we cannot use the semicolon over here because we are using these values. If I use semicolon, that means termination. This is the example, that is $1 million question that is used, even though this one is this one, clear screen. This is again the another form, that is the hash define clear screen. This is the value, this one, that is in alphanumeric form. Then whenever clear screen appears in the program, it would automatically be replaced by this one. That is, it would be replaced by this one before compilation begins. There is perhaps a more important reason for using the macro definition than mere readability. That is, this is the more important reason, or this is the most important reason for using the macro definition than mere readability. Suppose a constant appear many times in the program. This value may be changed someday to this one. Ordinarily, we could not go through the program manually change. If we define the PI, you make one change, that is hash define directive as this one. Beyond this, the change will be made automatically to the occurrence of PI before the beginning of the compilation. That is, if I this paragraph says if I want to change any values, that can also be give or that can also be changed by using the concept of the macro definition. In short, it is nice to know that you will be able to change the value of a constant at all the places in the program by just making the change in the hash defined directive. That is, it can be done by making the change in the hash directive, make the changes in the program. But the same purpose could have been served had we used in the variable pi instead of the template pi. A variable could also have provided meaningful name for a constant and permitting one change to affect the occurrence of the constant. Then why not use it? For three reasons. That is, what are the three reasons why we are not using the occurrence of the, or why you are not using the constant? First of all, it is insufficient. That is, since the compiler can generate faster and more compact code for the constant than it can for the variable. Second, using any variable. So this is the first point. That is, the compiler can generate the faster and the more compact code for the constant than it can for the variable. That is, it is better to use the variable other than the macro. So this paragraph says that but the same purpose could be served. That is, the same macro definition purpose can be solved by the using the variable, that is the pi variable. That is, the same purpose can be solved by the pi, then why we are using the macro definition? That is, it can have a meaningful name for a constant and permitted. So what are the main reason why we are not using the variable? Because that is insufficient, because the compiler can generate in a faster way and we cannot generate the, or we cannot take the variable, or we cannot define the variable again and again. Secondly, using a variable for what is really a constant encourages sloppy thinking and makes the program more difficult to understand. Third, there is always a danger that the variable may inadvertently get altered somewhere in the program. That is, variable may altered in the, or may get altered in the program. But if you define the macro, that cannot be altered easily in the program. These are the three methods why we are not using the variable, or why we are not using the variable instead of the macro definition. Therefore, using hash define can produce more efficient and more easily understandable program. That is, if I use hash define, that can produce more efficient and the more easily understandable programs. This directive is used extensively by the C programmers, as you see in the many programs. Following three examples shows places where this, that is the macro directive, is properly used by the C programmers. A hash define directive is many a times used to define the operators as shown below. That is, it is used to define the operator as well. This is this AND operator. This is the AND function is used as this one. That is a double ampersand. This OR is used as a 2 pipes. This is this one. So these are the two lines that shows the macro definition. That is, whenever I use AND, it must be replaced by this one. Whenever we use OR, that must be replaced by these two pipes. Then main function will be started. Then defines the variable. What are the variable? First of all, int f equals to 1. That is one variable. Second is x equals to 4. Third is y equals to 90. So three variables are declared. One is f, one is x, one is y. Then check the condition by using the, or by use the if function. That is, if function, if condition will be used. Then what is the input? That is, check the condition if f is less than 5 and. So in this, if it is used and, that will be replaced by the this one. And this one or will be replaced by the double pipes. That is, or means either one of the input is correct, then the output will be correct. That is or. And means both the input must be correct, then only the output will be correct. That is, if both the input are ones, then only the output is ones. Otherwise the output is 0. But in OR, either one of the input is 1, then the output is 1, otherwise 0. That is, if this condition is true, then print or printf, your PC will always work fine. Otherwise, print in front of the maintenance man. This is the example that how macro will be used as a or macro will be used to define the operators. Then this is a term that is used to replace a condition. This is also a condition that will be replaced in the program. This is the operator that is used, that is the AND. Then arrange. Arrange means this is the condition that is used, that is whenever we use the word arrange in the program, that would be replaced by this condition only. This condition is also replaced by the hash defined directive. This is the main function. Then a equals to 30, that is the variable is declared that a has a value 30, then uses the if arrange. So what is the condition? The condition is if a is greater than 25 and a is less than 50, that if the values lies between 26 to 49, then only printf within range, else printf out of the range. This is the condition. That this condition is also given in the macro directive, that is a hash defined directive. Next point says a hash defined directive could be used to replace even an entire C statement. That is this program can also be used to replace the entire C statement. That is, any one statement can also be replaced by using the hash defined directive. This is used hash define found. That is, found is a directive name that can be used, that is used to replace this one. That is printf the Yankee Dongle or Doodle virus. Then main function will be used. Then use the signature. Then if signature equals to y, that is, if I use signature equals to y, that is, the signature has signature contains the y character, then print the value that is from. That is print what the print, that is printf the Yankee Doodle virus, otherwise printf. So this says we can also give the macro condition, or we can also give the C statement in the macro condition. Then next is macros with arguments. That is how macro will be used with the arguments. This says the macros that we have used so far are known as the simple macros. Macros can have an argument also, just as a functions can. So that is a macro. That is, they are also using as a function. We are also defining the arguments. We are also defining the variables in the macro. Here is an example that illustrates the fact. This is hash define area x. That is, this will be used. This is the macro, that is the define. Then area x, that is the area x will be used. Then what is the condition? That is 3.14 into x into x. Then it uses the main function, means carrying out with the main function. Then float r1, that is the r1 is used as a float, that is a float type. Then 6.25 is defined as in the r1 value, r2 as a value that is 2.5. then there is a variable that is a. So r1 and r2 are the variable that have a different values, that is 6.25 and the 2.5, and the last variable is the a. So one r1, one r2, one a, both are of, or all the three are of float type. Then uses the function that is area r1, and that output will be stored in the a. Now what is the area? What is the macro definition for the area? This is the definition for this one, that is 3.14 into x, that is the area. That output will be stored in the a, and the output will be printed. This is the example. This is this one, that is area is 3.14 into 6.25 into 2.25, that is x into x. In this program, wherever the preprocessor finds the phrase area x, so whenever it finds the phrase area x, it will be replaced by this one. However, that's not all, that the x in the macro template is an argument. So this is an argument that is used that matches the x in the macro definition. The statement area R1 in the program causes the R1 to be substituted for the x. Therefore, the area R1 is equivalent to this one. That is, if I use x, so this x will be used here. If I use area R1, so this will be replaced by the R1 and R1. Then 3.14 into 6.25 into 6.25. In this concept, the x will be replaced by the R2. That is 3.14 into 2.5 into 2.5. That is output this one. So this is the way how we can also define the argument in the variable. That argument depends on the function to the function. After the above source code has passed to the preprocessor, what the compiler gets to work on will be this. This is the program that shows the macro will be how macro will be used, or how we can give the argument in the macros. First of all, the variable will be declared as a float that has a value this one. This is the same example. That is, after the above course had passed the preprocessor, what the compiler get or work like this one. So this is the work that will be done by the compiler. This is another example that shows the macro with the argument. That this you have to study by your own, and if there is any doubt, then please clear the doubts. I am giving the hint. This is the y will be used, and this y will be used over here. That is each digit. In this, if there is a ch, then ch will be used. This is ch is greater than 48 and less than 57. That is, it lies between 48 to the 57. These are the some points that remember. Then whenever we write the macro argument, whenever we write the macro with the argument. What are the rules? What are the points to remember? Be careful not to leave a blank between the macro template and its argument. That is, do not leave any blank. That is, if I write this one instead of this one, the x would become a part of the macro expansion. That is, it is always advisable to write the along with the x with the area. That is, there is no space over here. The entire macro expansion should be enclosed within the parenthesis. That is, this should be enclosed within the parenthesis. Then macro can be split into the two lines with the backslash present at the end of the line. Suppose if my program first line is not available, is not sufficient to store the data, then it must be terminated, or it must be converted into the two lines, multiple lines, by using the backslash that is present at the end of the each line. That is present at the end of the each line. So this is the next part. So first, what we have discussed, there is no gap between the name and the argument. Next, the entire macro expansion will be enclosed within the braces, that is the curly braces. Next, that can be divided into the multiple lines by using the backslash. Then, if for any reason backslash, then if for any reason you are unable to debug a macro, then you should view the expanded code to see how macros are expanded. That is, we can also use we can also view the macro code by using or by right clicking on the view code. If your source code is present in the pr1.c, then the expanded source code will be stored in the pr1.i. That is, you need to generate this file by giving the command cpp, that is a C preprocessor. Next category, next topic is your macro versus function. That is, how macro, or what is the difference between the macro and the function. This says in the above program a macro was used to calculate the area of the circle. As we know, even a function can be written to calculate the area. The macro calls are like function calls. So what is the main difference between the macro and the function? In a macro, the preprocessor replaces the macro template with its macro expansion. That is, whenever we use the macro, then the preprocessor, that is a CPP, C preprocessor, replaces the macro template with the macro expansion. In a stupid, unthinking, literal way. As against this, in a function call, the control is passed to a function along with the certain argument. Some calculations are performed in the functions and the useful value is returned back from the function. This brings to a question: when it is best to use the macro with the argument and when it is better to use a function? This is the most important line. So first definition is it replaces the macro template with the macro expansion. But in function it will be called once and the argument are passed, and then output will be stored back to that point only from where it is called. Next point or the next difference is that usually macro makes the program run faster but increase the program size, because we have to define the macro definition also in the beginning. So it increases the size, program size, I agree, but it makes the program run faster. Whereas function makes the program smaller and the compact. Compact means it is of smaller size, it is of good quality, but it runs very slow. So this is the main difference. That is, a macro program will be run faster, but the program size is high or the increases, whereas the function makes the program size smaller and the compact. Next, if we use a macro 100 times, the macro goes into the source code at the 100 different places. On the other hand, if function is used, it will be called from the 100 different places in the program. It would take the same amount of space. This is the same line. Next difference is that makes or therefore slow down the program. This gets avoided with the macro. They have already been expanded and placed in the source. Moral of the story is that if the macro is simple and sweet like in a program, it makes nice forward, avoids the overhead. On the other hand, if we have a large macro, it will be used fairly often. Perhaps we ought to replace with the function. That is, it is not advisable to use the macro because that makes the program lengthier and but yeah, I agree, it makes the program faster. But if the program is lengthier, then there are so many bugs in the program. So what is the benefit of writing the long program? No benefit. So generally or usually whenever we have a large program, large capacity, large requirement, so it is better to use the functions in place of the macros. Next, file inclusion. That is the second preprocessor that is used, that is a file inclusion that is used. Before this, let's take a break for the 5 to 10 minutes and then come back. Then starting with this topic, that is a file inclusion, that is how file will be included in the C program. So let's take a break for the 5 to 10 minutes, then come back starting with this topic, that is a file inclusion. So let's take a break. Let's continue with the next topic. So come back from the break, continue with the next topic, that is a file inclusion. So this is the file inclusion topic, that is how file will be included. That is our second preprocessor directive that will be used in this chapter. So first what we have used is hash define. Next is hash include, that is a file inclusion. This directive causes one file to be included in another. That is how one file will be included in another. That is a inclusion, file inclusion. The preprocessor command for the file inclusion looks like this one. This is the example that looks like that how file inclusion will take place. That is a hash include file name. and it simply causes the entire content of file name to be inserted. That is, the entire file name or entire content of the file name to be inserted in the source code at that point of the time, at that point in the program. Of course, this presumes that the file being included is existing. That is, the file that is included is existing file. Now, when and why, or why and when this feature is used? It is used in two cases. What are the two cases? If we have a large program, that is, if you have a big program, the same code is divided into several different files, each containing a set of related functions. That is, dividing the main program, dividing the large program into the subparts, into the different files that then we include, or then we use the hash include file name. So it is a good programming practice to keep different sections of the large program in a separate way. These files will be separated, or these files are using the hash included at the beginning of the main program file. That is, uses the hash include. There are some functions and some macro definitions that need, or that we need almost in all the program that we write. These commonly needed functions and macro definition can be stored in a file, and that file can be included in every program we write, which would add all the statement in this file to our program as if we type them in. That is, we can write, or there are some function that we almost use or in the program, so use the hash include so that that program will be used, or that file will be used by using the file inclusion directive. This is it is common for the file that are to be included to have a .h extension. This is the .h extension? No. So it is mandatory to use with the .h extension, that stands for the header file possibly. This is hash include file name, hash include file name. The meaning of each is given below. This is the meaning, that is hash include go to .c. This command would look for the file go to .c in the current directory as well as the specified list of directories as mentioned in the include separate path that might have been set up. That is, uses hash include go to .c that includes the directory, the separate directory for the go to .c. Then next is hash include go to .c that would look for the file go to .c in the specified list of directories only. This is the go to .c. That is, there exist two files, or there are two ways to write hash include statement. That is, hash include will be used in the two parts like this one and this one. So either we use the double quotes, or either we use the less than sign and the greater than sign. Either these signs will be used, or either this sign will be used. The include separate or search path is nothing but a list of directories that would be searched for the file being included. Different C programmers let you to search the path in different manners. If we are using the Turbo C++ compiler, then the search path can be set up by selecting the directories from the options menu. On doing this, a dialog box will appear. In this dialog box, use the include directories. We can specify the search path. We can also specify the multiple include path that are separated by the semicolon. This is the way how it will be used. That is, using C, TC library, C, my library, D, library files. The path can maximum of 127 character. That is, the path that is given is of maximum of 127 character. That includes both the absolute and the relative path. This is the absolute path. This is the relative path, and absolute means starting with the folder. These are the absolute paths. Then next category of the macro is compiler or the conditional compiler. So till now we have covered hash define. Now next category, then we have discussed about the file inclusion. Now the next category is conditional compilation. That is, how condition will be compiled, or how conditional compilation will be used. So this is, we can, if we want, have the compiler skip over the part of a source code by inserting the pre-processing command. That is, we can also give the part of the command or the part of the program, or we can also skip over the main part of the source code by inserting the pre-processing commands. What are the pre-processing commands? This is hash if definition hash and if. That is, if I use hash if def or hash and if, which have a general form like this one. This is the general form that is used, that is hash if def. That is, if def will be used, there is a macro name, then there is a statement 1, statement 2, statement 3, and there is a end if. So it starts with the if def and it ends with the end if. If the macro name has been defined, the block of code will be processed as usual. That is, if I define the macro code, the code for the macro will be enabled or will be executed or will be processed as usual, otherwise no. If I do not use the macro name, that will not be used. Where would this will be useful? Means where would be useful? When you would like to compile only a part of the program, means what are the cases in which hash if def macro name and the end if will be used? It is used in 3 cases. That is, what are the 3 cases? Whenever you have to comment out obsolete line of code, that is to comment out line of code. That is, it often happens when a program is changed or that a program is changed at the last moment to satisfy a client. This involves rewriting some part of the source code to client satisfaction and deleting the old code. But using the programmer, or if the programmer are familiar with the client who change their mind and want the old code back just the way it was, now you would definitely not like to retype the deleted code again. Means this is a scenario. Suppose my requirement is that I have to write the code in the C .NET programming language. My client gives me the requirement and I have generated the code for that, right? But after some time my client told me that no, this code is not correct. Please correct some part of the code. I correct it. I delete the old code, means the code that is not satisfied with the programmer. But sudden my programmer mind changes. My programmer said to me that no, that code is okay. This is not a good code that you have written again. No, that would be the okay code. Now I'm so angry. Why? Because that code would be deleted. One solution is that in such a scenario, don't get angry. Put the old code within the pair of this one combination. That is, make the old code as a comment in this combination. But we might have already written a comment in the code that we are about to comment out. This would mean we end up with the nested comments. That is, we end up with the nested comments. Obviously, this solution will not work since we can't nest comments in C. That is, we cannot nest the comment, we cannot use the nested comment in C. Therefore, the solution is to use conditional computation or conditional compilation as shown below. The solution is that whenever we have to generate or whenever we have to write the old code or retype the old code, so there is a solution to use the conditional compilation as shown below. This is the main function that is used. One is if def will be used for the starting purpose. What is the macro name? The macro name is OK. So this is the macro name, that is OK. This is the starting if def. There is statement 1, there is a statement 2, there is a statement 3, statement 4. So 4 statements are used. Statement 2 detects the virus. This specifics to the stone virus. This is the definition or the using with the comment, that is put the old code with the comment. Then uses hash and if, that is this macro name is OK, that have a 4 statement and that macro starts with the if def and ends with the end if. Then 3 statements more are executed, that is 5, 6 and 7, and then the main function will be closed. Here the statement 1, 2, 3 would get compiled only if the macro has been defined. Only if this is defined, then only these 4 will be executed. And we have purposely omitted the definition of macro OK. At a later date, if we want this statement should get compiled, that we require to do is to delete the hash if and the end if statement. That is, if this will be deleted, this will be deleted. I can use the statement, I can use the macro very well. Next point says a more sophisticated use of HFDIV has to do with making the program portable. So whenever we make the program portable, that is we make them work on two totally different computers that have a different operating system, that have a different capacitor. So in that cases we also use the hash include, that is it can work with the portable computers. That is you are expected that this program would work more precisely, then you can use this one. You can do so by isolating the lines of code that must be different for each machine by making them off with the hash if def. For example, this is the part. There is a main function, then there is a if def Intel code suitable for a Intel PC. Then else, this is the code suitable for a Motorola PC. Then end if code common to both the computers. When you compile this program, it will compile only the code suitable for the Intel PC. Why? Because it is available for the Intel program and the common code. It is not used for the else part. This is because the macro Intel has not been defined. Note that the working of hash if def, else if def is similar to the ordinary if else condition. If we want to run the program, we simply use the hash define Intel. That is, we use the we want to compile the macro definition, simply use the definition purpose, that is a hash define Intel. Sometime instead of using this one, the if NDEF directive will be used, that is if not defined. This is the if defined, this is if not defined. That works exactly opposite to the if def. The above example, if written using if def, would look like this. This is the example, that is the that is using the if and def, that is a if not defined. That is if not defined Intel, then use this one, otherwise use this one. Suppose a function myfunc is defined in the file myfile.h, which is hash included in a file myfile1.h. Now in your program, if you hash include both myfile and the myfile1, the compiler flashes an error, that is a multiple declaration of the my function. So instead uses if and def myfile define myfile underscore h. So this is the way how macro will be used. Now next category is hash if and the else if, that is the elif means else if the directive. This is the next macro. So till now we have covered hash include, hash define, hash if def, if and def. Next is hash if and the hash elif directive, that is a macro. The first line says the hash if directive can be used to test whether the condition evaluates to non-zero value or not. That is, to check the condition, we use the hash if directive. That is used to check or test whether an expression evaluates to non-zero value or not. If the result of the expression is non-zero, then the subsequent line is up to hash else, else if and if are compiled, otherwise they are skipped. This is the example for the hash if. This is hash if test is less than equals to 5. That is, check the condition that the test is less than equals to the 5. Then statement 1, statement 2, statement 3. Then else, hash else, statement 4, 5, 6, then there is the and if. That is, if the test, that is the macro name is test, that is less than or equals to 5, that is either 1, 2, 3, 4, then statement 1, 2, 3 are executed, otherwise statement 4, 5, 6 are executed. And there is a end if means ending of the if. If the expression test is evaluates to true, then statement these are compiled, otherwise these are compiled. In place of the expression this one, so in place of this one, other expressions like level equals to high, level equals to low, or adapter equals to GCA can also be applied. Means we can test the condition, we can check by this one also. If we so desire, we can have a nested conditional compilation. That is, we can also use the nested conditional compilation. This is the nested one. If this is equal to this one, else if this equals to this one. That is, this is also used, and in the next part, that is in the nested part, this is also used. So this is if adapter equals to VGA, this is the equality sign, that is check for the equality. If it is equal, then prints the code, that is the code for the video graphic array. Otherwise else, if this adapter equals to SVGA, this is VGA, this is SVGA, then code for the superior, else code for the extended graphic. Then there is a end if. This is the end if for this part. This is the end if for this code. This is one code and this is one code. This end if is for this one. So this is the else part for this. This is the else part for this. The above program segment can be made more compact by using the another conditional compilation using the elif. That is, this makes the program more understandable, more readable, and the more compact. The same program using this directive can be rewritten as, that is, it can be rewritten as this one. Means simply the else part will be skipped. This will be skipped, this else part. Right? Only the two if, that is the elif, will be used. That is elif, that the same as the end if, or elif is same as the else part. That is, if adapter equals to VGA, that is, if the adapter has a value, if the adapter equals to VGA, then print the code for the video graphics array. Otherwise else if use adapter equals to SVGA. That is, if the adapter equals to SVGA, then use the code for the super video graphics array. Otherwise else use or print code for the extended graphic array. Then there is a if else. So these are the basically conditional directives. Next is a category of the miscellaneous directive. That is, what are the miscellaneous directives? So these are the important directives that we have studied. Now next category is your miscellaneous directive. That is the extra directive that is also used in the C programming. This says there are two more preprocessor directive available. That is, there are two more preprocessor directives available, though they are not very commonly used. That's why they are known as miscellaneous directive. That is not commonly used, but they are used sometimes. What are those? That is undef and the hash pragma. So these are the two directives that is used, that is also used, that are known as the miscellaneous directives. So one is undef, one is pragma. So first one is undef directive. That is the first one. This says on some occasions it may be desirable to cause a defined name that is, on some occasions it may be desirable to cause a defined name to be undefined. That is, there are some situations when we use or when we declare the defined name to be undefined. That is, declare the defined name, that is, if I use hash define, that would be changed into the undefined. That would be changed into the undefined, that is a undef. So one is hash define, that is a hash def. One is the hash undef, that is a undefined. In order to undefine a macro, in order to undefine a macro that have already been earlier defined, that is, we can already define the macro, that is hash include define. So we can undefine by using the undef macro template. That is, instead of using the hash define, we can use the undef macro template. This is a syntax that can be used. Therefore the statement, the statement hash pentium or hash undef pentium. So this is the undef pentium, that is, we can undefine the macro that have already been defined. What's the name of the macro? That is pentium. This would cause the definition of the pentium to be removed from the system. That is, the definition of the pentium that we have already given is removed from the system, removed from the C programming language. Next point or next line says all subsequent hash if def pentium, that is the hash if def pentium statement would evaluate to false. That is, the if def means if definition. That is, if we check the condition by using the hash if def, that is, if there is a definition of the pentium, that always evaluates to the false, that always evaluates to the 0. Why? Because there is no pentium statement. Why there is no definition for the pentium statement? Because we have already undefined the pentium macro. In practice, seldom you are in practice seldom are you required to undefine a macro, but for some reason, if you are required to, then you can make, then you know that there is something to fall back upon. That is, if you declare the macro and you have by mistakenly you have undelete or undefined the macro, then it is impossible to come back or get the solution for come back to the macro. That is, again you have to include, again you have to define the macro, again the same process will goes on. That is the undef macro. Next is your pragma directive. So this is the done, that is the how to undefine, that is the defined macro will be undefined by using the undef directive. Next is pragma directive. This is another special purpose directive that you can use to turn on or off certain features. So undefined is used to undefine the macro itself, but the pragma is used to turn on or off the certain features that is available for the directives. Pragmas vary from one compiler to another compiler. Suppose I am using Turbo C compiler. That in that the pragma is different, but in C++, that is in Turbo C++, the pragma is different. There are certain pragmas that is available with Microsoft C programmer that deals with formatting source listening or source listing. That is, there are multiple or there are certain pragmas that is available with Microsoft C compiler. That is, there are more than or there are general pragma that is available with Microsoft C compiler that deals with formatting, source listing and placing comments in the object file that is generated by the compiler. That is, we are using or we are dealing with the formatting, or we are dealing with how to format source listing and placing them statement or placing the statement in the object file that is generated by the compiler. Turbo C compiler has got a pragma that allows you to suppress warning generated by the compiler. So this is the pragma that is used to either turn off the features or either turn on the feature. The best example is that whenever we write any program, there are some warnings that if you run this program, the program will not execute, it will capture your memory. These are the various warnings that is available. But frankly speaking, we generally ignore that warning and compiles our code. That warning is suspended or that warning is suppressed, that is, that warning is wounded up, and that wounded up process or that suppressed warning process can be allowed to generate the or can be suppressed by using the pragma directive. That is, if we got a pragma that allows you to suppress the warning, that allows you to remove the warning that are generated by the compiler. Some of these pragmas are discussed below. So these are the different pragmas that is available to suppress the warning that is generated by the compiler. But first pragma that is used is hash pragma startup and the hash pragma exit. This is the first pragma that is used. That is, at the starting phase we use the hash pragma startup. At the ending, that the exit stage, we use the hash pragma exit. That it is start with the startup and it is ending with the exit. These directives allow us to specify functions that are called upon program startup before main function or the program exit, that is just before the program terminates. Their usage is as follows. That is, what is the usage or what is the main purpose? So this allows us to specify the function that are called up whenever we use the start or whenever we start the program. For example, before the main function or whenever we terminate the program, that is after the curly brace will be closed off the main function. Now what is their usage? The usage is void fun1 parenthesis, then void fun2 parenthesis. So two functions are defined. Two functions are defined. What are the two functions? That is fun1 and the fun2. Then hash includes startup fun1, that is the use the pragma directive, that is the pragma startup fun1. Then uses pragma exit fun2, that is use this is a line, this is the next line, that is using the startup fun1, using the exit fun2. So two functions are used, one is the startup function, one is the exit function. This is the main function that is used. Then if I use hash pragma startup fun1 hash pragma exit fun2, that is it is used for startup, it is used for exit. Then uses the main function, that is start with the main function printf inside main, that is it uses with the printf inside the main. Then this is the definition of the function. This is the first of all there is a fun1 that have a return type void. Then uses the statement inside fun1. So this is the definition of the fun1 function. Then this is the definition of the fun2 function, that is inside fun2. So first of all this will be used, that is a main printf inside main, then fun1 that is inside fun1, then fun2 that is inside fun2. And this is not main, this is main. This is the program that shows first of all the pragmas are defined, that is at the startup we use the fun1, at the exit we use the fun2. That is whenever we begin with the or before the main function, it is the startup phase, it use the function 1, and then the exit, that when the curly braces closes, it exit from the function, it uses the fun2 function. And these are the two functions that must be declared before using the macro or before declaring the macros. This is the output of the program. First of all there is the inside fun1. Why? First of all, as I told you, before main these two will be used. First of all startup will be used before main, that is before main there is a fun1 will be executed, and in fun1 there is a return inside fun1. Then the main will be executed, that is inside main. Then exit will be executed after this step, after this braces. Then that means fun2 will be executed, that is inside fun2. So the output will be inside fun1, inside main, and the inside fun2. So this is the way it shows. Before main there is a pragma startup will be used, and after the curly brace the pragma exit will be used. Note that the functions fun1 and the fun2 should neither receive nor return any value. Why it should not receive any value or return any value? Because this is the void, this is also a void, and these are the empty empty parentheses. So this will not receive or not return any value. If we want two functions to get executed at startup, then their pragma should be defined. That is, if we want, or if a requirement of if there is a requirement that two functions to get executed at the startup phase, then their pragma should be defined in the reverse order in which you want to get them called. That is, this must be defined in the reverse order in which they get called or they get called. That is, if I want to use the fun2 first, that uses hash includes pragma startup fun2 and hash include exit fun1. That should also be used. Now the next category of pragma is pragma warn, that is it is used for the warning functions. This says this directive tells the compiler whether or not we want to suppress a specific warning. That is, whether or not we suppress the warning, or we have to, or we want to suppress the warning or not. That is a hash pragma warn. That is the next part that tells the compiler whether or not we have to suppress the warning. The usage is shown below. This is the usage, that is hash pragma warn RVL, that is returning the value, parameter not used, unreachable code. That is these are the three codes that is used. So one is the return value, one is the parameter not used, one is the unreachable code. This is the definition of the function, that is int f1. This is the first function that is used. There is a value that is used, that is a int a equals to 5. That is one variable is declared, that is a variable that is of integer type, that is a value 5. Then void f2, that is f2 will be used, and int x, this is the argument, then printf inside the f2. Then int f3 will be used, this is declared, return x, and then x plus plus. Then after the void main will be declared. This is first of all f1 will be used, f2, f3. Now if we go through the program, there are three problems immediately. Through promise, f1 does not return a value. This does not return a value because it is declared as a this one. It is declared as a int, and in this there is no argument. The parameter x that is passed to f2 and not been used anywhere in f1. The control never reached x plus plus in f2. So these are the various warning that is used. So if I compile, we should expect the warning indicated the above problems. However, this does not happen since we have suppressed the warning using the hash pragma directive. We have declared the hash pragma directive, that is a return value, parameter not used, unreachable code. So this warning can be suppressed. This does not reflect on the screen. That is the this will be used for suppress the warning. If we replace the minus and the plus sign, that this warning will be flashed on complication. That is, this warning should be indicated if I use the plus sign, plus sign, plus sign. If there is a minus sign, that warning should be suppressed. If there is a plus sign, the warning should be displayed. Though it is a bad practice to suppress the warning, at times it becomes useful to suppress them. Whenever we want that there is some complication in the program, that we have to suppress the warning. For example, if you have written a huge program and trying to compile it, then to begin with, more interesting in locating the error rather than the warning. At such time you have to suppress the warning. Once you have located the error, you may turn on the warning by placing the plus sign over here. So that's all for the chapter. Now this is the summary. Now let's see the summary. The first point says the preprocessor directive enables the programmer to write programs that are easy to develop, read, modify and transport, that is portable to different computer systems. That is the main advantage, that is writing the code before the compilation. That is before the compilation, this is a step, that is a preprocessor step that makes the program more understandable, more readable, develop, read, modify and maintain the code. Then next point says we can define use of various preprocessor directive. That is, we can also use, or we can also make the use of various preprocessor directive such as hash define, hash include, hash if def, else if def, if else. That is, we can make use of these processor in the program. Then the directives like this undefined and the pragma is also useful in the directive or in the preprocessors. Now this is the exercise that you have to solve, and if there is any doubt you can ask from me. These are the true and the false. These are the various questions. What will be the output of the following program? These are the questions. These are the scenario program based question. You have to define the, or you have to find out the error. Now this is the objective based question, that is the write the macro definition, that is writing the program code. So that's all for today's session. Thank you so much everyone. In the tomorrow's class I will be starting your next topic, that is the next chapter, that is the chapter number 8, that is arrays. So let's stop over here only. In the next class, starting with the array. I'm repeating again one more thing. Now please start practicing the exercises. We have already finished the 7th chapter, that is till chapter number 7. So please practicing the exercises, and if there is any silly doubts, then please feel free to ask from me. I am here only for you. So please ask the doubts from me, so that you will be able to understand the concept very clearly. So please ask the doubts from me. So thank you so much everyone. Bye bye. Yeah, one more thing, I'm so sorry, the class will be on Monday, not on tomorrow, because tomorrow is a Saturday. Thanks a lot Larry. Remind me that tomorrow is a Saturday, today is Friday, so now the class will be on Monday only. Okay, thanks a lot Larry.